In this segment, we are going to talk about gap theorem, Brewer's gap theorem. I think this is probably one of the most important elements to understand, which basically will put Cassandra in the right zone. Because right now, you all might be from RDBMS background and asset properties is floating in your mind, right? So why don't we neutralize with some base, right? Anyway, let's not talk about that base, at least as of now. So what is gap theorem? Gap theorem is an acronym. By the way, it's also called as Brewer's gap theorem, is an acronym of consistency, availability, and partition tolerance. The important aspect to note here is when you are talking about CAP, the theorem states that you can get two strong attributes and one attribute is going to be a weak attribute. Meaning the theorem doesn't say you're not going to get the third attribute. You will, but it's a weak attribute. Now, why it is so? And what do we mean by a weak attribute? Let's take a look at that. So what I'm going to do is I'm going to draw two architectures when we are talking about a distributed system. So let us assume this is a master and we've got a bunch of nodes, and let's assume these are all the slave nodes. The application will always talk to the master for the CRUD operations. And the master is like the orchestrator of where the data needs to go. Let us also assume, at least for now, the replication factor is equal to 3. That means I'm going to store the data in triplicates. A single insert or a single data put operation will store the data 3 times in 3 different nodes. Let's just assume it for now. You might wonder and say, why did you say 3? I'll give you a scientific explanation of why 3. And anything less than 3, right, causes system degradation. And anything above 3, you will basically see diminished law of diminished returns kick in. So 3 is the sweet spot, like the Goldilocks zone where our planet Earth is. Anyway, coming back to Cassandra. All right, so application is contacting master, and remember 3 copies. So let's do a role play. Application is saying, okay, at time t1 you insert the value a. Replication factor 3. So master is going to say, okay, you node you get a the data, you node you get a the data, and you as well. You must have noticed I skipped 2 nodes here. Again, a concept that is something that I'm going to come to in a little bit, right? And this has a bearing in the way you set up the physical Cassandra cluster, as in your server room, in your data center, on the cloud, wherever there might be some hardware dependencies, etc., that you need to factor in. Anyway, that later. But right now, T1, I inserted the data A and it went out there and put it in all of this. It might also say that, look, I have put the data in this node and I might asynchronously put the data in these two. At least if I store the data in one node, I can respond back to the client, okay, I'm done. And these two I can do asynchronously. The application at time T2, probably as part of the same thread of operation, this is an insert statement. It can basically say, get me the A. Get me the record A. So this is an insert statement. This could be a select statement. Now the master knows, okay, this is the order in which I saved the data. It can easily reach out to this node and fetch the data. In the world of CAP, that's called strong consistency. Isn't it? That's strong consistency. I inserted the data. the next very microsecond, if I were to fetch the data, I will get the last committed view, the last put, the view of the last put insert. Strong consistency. If this node were to go down, do I have the data in other nodes? Yes, I do. Will I be able to fetch the data from the other nodes? Absolutely. Now, how does the master do it? That's up to the system. So let's assume for now that the system does know that there are two other copies sitting around. And if this node goes down, I am able to fetch the data. That's called partition tolerance. The system is able to tolerate a partition or a node going down. But what happens if the master goes down? You can say, well, don't we have a concept called secondary? This is my primary and this is my secondary. Yes, of course we do. But do you think the secondary will become primary in a matter of milliseconds, microseconds? It's not. It's going to be several seconds. So what happens during that delta t when the secondary is becoming primary? We have a system outage. Eventually, after the delta t has elapsed, the secondary does become primary and the system does become available. But don't you think availability is a weak attribute? That's what I mean by weak attribute. It's not that you don't have availability. Of course you do. But it's a weak attribute. So these type of systems, what systems am I talking about? Master slave. This is a master slave architecture. This is going to deliver strong, consistent, partition tolerant systems, CP system. That's what they are.